are bonded with OH. R, it means the aliphatic group that has what? That has symbol of CH3 methyl, C2H5 ethyl, and so on. So the R, OH, it means what? It means here methyl alcohol, for example. R, it means CH3 and attached with OH hydroxyl group to form one molecule of what? One molecule of alcohol. So here, the CH3, we can replace the R here by many types of these groups that we have different types of alcohols. And we have another thing in phenol, the same thing in phenol. If I increase the number of OH of the phenol, we have another chemical compound of phenol or another types of phenol. After that, we have phenols. We will start with phenols. دلوقتي احنا هنشتغل الفينولز الاول وبعدين هنكمل بعد كده الالكولز. ليه؟ الفينولز المعلومات بتاعتها سهله جدا وبسيطه واليوزز بتاعتها كمان بسيطه. Let's go to see. We have phenols. They are hydroxyl aromatic group or aromatic compound, hydroxy aromatic compound, where one or more hydroxyl group are directly attached with benzene ring. So again, we have the definition of phenols. What are they? If you have an exam and you have defined the phenol, what's meant by phenol? They are hydroxy aromatic compound. Hydroxy, it comes out from hydroxyl group, OH group that attached with benzene ring. The same information here. So the aromatic compound is hydroxy aromatic compounds where one or more hydroxyl group are directly attached with benzene ring. By what? By replacing one hydrogen atom from what? Yes, excellent, from the benzene ring. So if I replace one hydrogen atom from the benzene ring, I put another hydroxyl group. Makes what? It makes the phenol. So here we have what? We have the phenol here. This is the structure of phenol, and we have another picture that's real picture about molecules of phenols. It's like what? It is form of crystals. Crystals like what? Like here. It's long crystals like this, and it has white colors. So here we have phenol. It has this color in the crucible here. And the other one, or the other picture that contains this ring of benzene, that contains any one of these black ball that or black spheres here. It has what? It represents one carbon atom. Black marble here, it represents one carbon atom. And we have the red ball or red marble here. It represent what? Represent O or oxygen atom, and the hydrogen represented by what? By the white balls here, small white balls. So here, this is what? This is the structure of phenol, benzene ring that replaced the last one or the first one of these hydrogen atoms in the carbon molecule, replaced by OH. OH, it called hydroxyl group. So here the symbol of phenol C6H5OH. This is phenol, and this is the crucible that contains the real shape of this phenol. And after that we have what? We have symbol of phenol is like this. We have benzene ring. If I have the shape of Kikuli or the benzene ring like the other one in the right hand, so both of them are right. We have the Kikuli form. We have the carbon atom that represented here in the benzene ring that attached with another carbon atom by double bond. In the left hand we have Kikuli form of benzene ring. So here the benzene ring that attached directly with OH, so it is called phenol. This is the molecule of phenol. And we have another one. Another thing about phenols, we have the symbol of catechol. What's meant by catechol? Catechol, it means another compound, but it contains benzene ring and double of OH or two OH group. Again, we have catechol. نخلي بالنا دايما من أي رمز موجود عندنا. phenols, alcohols, carboxylic acids, any type of compounds because I need them in chemical reaction. If you don't write the compound or structural formula of the compound in the right way, so the equation, all of the equation will be wrong. So here the symbol of catechol, it's what? It is benzene ring, and we have the carbon atom. Number 1, it's OH, and another one that replaced the hydrogen atom from the second carbon atom that contains OH. So here this is called catechol. And the catechol, it's different type of phenols. And after that we have another one. We have another type of compound here, symbol of byrogallol. Byrogallol, it has what? 3 of OH group. This OH group, it means hydroxyl group. Here we have 3 of what? Of the hydroxyl group that directly attached with benzene ring, forming another type of phenols that contains, that called what? That called byrogallol. So here we have 3 types of phenols. Number 1 phenol that contains 1 hydroxyl group that attached directly with the benzene ring, and the second one we have catechol that contains 2 groups of hydroxide group, and we have byrogallol that contains 3 types of what? Or 3 groups of OH. After that we have phenol that called carbolic acid. It is used in many things. It is used here in this picture by what? By poly paper clips. It's used in polymerization. Yes. Why? Because this carbolic acid, it means the compound that starts what? Start the reaction of what? Of polymerization. Let's go to see this. We have here, it is an organic compound. The phenol or carbolic acid is an organic compound that has a great industrial importance as in starting material in making polymers. How these polymers that formed? We have here, it's an organic compound. The phenol is an organic compound that contains the benzene and hydroxyl group that has great industrial importance. It starts the material or the starting material in making polymers. How come? We have this shape. Here we have the polymerization of ethene. How does ethene polymerize to become polyethene? Let's start to find out this. We have the stage number 1. I use phenol to make what? To make starting this reaction. So here we have the ethene is an alkene with the formula of C2H4. So the double bond makes it reactive. If I press the double bond, it will break by helping what? Helping with what? With the phenol. Let's go to see. If I double bond, if I press this bond like this, we have what? We have the bond will be broken to make what? To make open the chain in this molecule. So the double bond between the carbon atom is broken to make 1 or 2 open the chain to make connection with another molecule of what? With another molecule of ethene. So the second one, if I have another ethene monomer, that's the bond that broken like this and make one connection between these 2 molecules to form double molecule to form one chain, and we have, this is called addition polymerization. And we have another one of this compound or this molecule that's broken again to make this chain more than 1 time, more than 100 times, to make what? To make the polymer chain grows as more ethene monomers bond together. So here the stage number 4, here again we have the polymer chain grows as more ethene monomer bond together to make long chain, and this is called polyethene. And we have another one, another stage, we have branching of the occurs at high temperature and the pressure, or the catalyst that we use the phenol here to make what? To make one hydrogen atom that move away from the carbon and another molecule of ethene that makes what? Makes connection with the carbon atom here to make another open the chain. That's what? That's perpendicular with the first one. Again, we have the branching occur at high temperature and the pressure, or if the catalyst it is not used. So here we have the catalyst, if not used we have high temperature. So I use the phenol to start this chemical reaction and speed it. So here this is the catalyst, it is not used. So the one atom of hydrogen that move away to complete the chain or to close the chain from the left hand, and we have another compound or another molecule of ethene that makes connection with the second carbon atom in this chain to make another polymerization. And we have another one. The polymerization reaction, it's what it contains or continuous, and polyethylene is formed like this. We have many balls that connect to each other to form what? To form one line that called colony. It is like the colony. Colony here it means one line that contains many of these molecules of ethene to form what? To form polymer. So the uses of the phenol that start this reaction to complete in this way. So here we have, it is an organic compound. This is phenol. It's carbolic acid. It's the organic compound that has a great industrial importance as we're starting the material in making polymers. Polymers, we use it to make pipes of water. We have some kind of plastics like bags, like anything that use plastics. Plastics, it's one of the types of polymers that we use it to make many things. Like what? Like pipes, like bags, like some kind of pencils, anything of this. We have the preparation of phenol. Preparation of phenol is very easy to know it. Preparation of phenol, it's what? C6H5Cl. It means chlorobenzene. We add some amount of NaOH to chlorobenzene. You have NaOH, sodium hydroxide. That makes a reaction with chlorobenzene. And we have double substitution here. You know double substitution reaction from the secondary. We have double substitution reaction between OH group and Cl. So at high temperature and high pressure, about 300 atmosphere, this reaction takes place. Why? Because here phenol, it's difficult to make reaction in the normal way, in the normal conditions. So I have temperature, I prepare the phenol from what? Or under high temperature and the high pressure equal 300 atmosphere. So the chlorobenzene plus NaOH give us what? Give us C6H5OH, it's called phenol. And we have NaCl, sodium chloride solution. So here this is what? This is the preparation of phenol. Now we have a video about what? About preparation of phenol and some properties of alcohol. Let's go to see this video, and it's very interesting one. Let's go. We have here the phenol. Phenol, it means the compound that we use it in many industry. We have here add few milligrams of phenol. We have some kind of reaction that's happened by phenol. So we have this small amount of these phenols and add some amount of what? Of catechol and some amount of pyrogallol like this to make what? To make differences between them. The difference between these types, phenol and catechol and pyrogallol. So they dissolve phenol in water. Dissolve phenol in water. So it doesn't dissolve in water. And we have another one of the catechol and another one. We have another reaction that's 1 or 2 drops of FeCl3. To make what? To make reaction. It has violet color that appears like this. So it is the reaction of phenol and pyrogallol and catechol with what? With this compound. And we have many one of them. Catechol, it has green color. And we have phenol, it has violet color. And the other one that has blue color. And the first tube, a drop of aniline, red color, of the phenol. To make what? To make this reaction. So this the reaction until dissolve HCl that dissolve inside. So here a few drops of HCl To make what? To make reaction here. So we have different thing here that's happened. We have the reaction that happened between the three types of this compound. And we have what? We have this reaction, and they have what? They have the same color here. So we have the physical properties of phenol. Physical properties of phenol: it is a solid corrosive substance. Corrosive substance, it means what? It means it is a type of substance that absorb water from our skin. Like what? Like hydrogen sulfide or hydrogen sulfate or concentrated acids. So, or another one, we have NaOH concentrated. This is caustic soda that makes corrosive substance. It means absorb the water from skin. So it is solid corrosive substance, and it has characteristic odor. Characteristic odor, it means what? It means it is a special type of odor of what? Of phenol. So from the physical properties of phenol, it's what? It is the solid corrosive substance, and it has characteristic odor. Characteristic, it means a special odor of this compound. And we have another thing about this physical properties, and it melts at 43 degrees centigrade. Again, the physical properties of phenol: it melts at 43 degrees centigrade, and it is springly soluble in water. It doesn't dissolve in water fast. Why? Because phenol, it appears like oil. So the phenol in water, it makes a layer like oil. So it has less dense than water in some kind of this dissolving. So the physical property of phenol, it doesn't dissolve in water easily. So it melts at what? At 43 degrees centigrade, and it is springly soluble in water. We have from the physical property of phenol, we have solubility in water increases by increasing the temperature. If you have hot water, it dissolves easily. But if I have cold water, it doesn't dissolve in cold water. So the solubility in water, it increases by rising temperature. It becomes completely impossible or immiscible in water at 65 degrees centigrade. Again, here we have the cold water, and the phenol doesn't dissolve inside. If you increase the temperature gently, it doesn't dissolve also. But at 65 degrees centigrade, it's completely miscible in water. So the miscibility of this phenol compound, it's at what? At 65 degrees centigrade. So if you have an exam and write the physical properties of phenol, or two or three properties of phenol, you must write these things. Okay, and here we have, it's very important to know this, it becomes completely miscible in water at 65 degrees centigrade. After that, we have it has acidic property. Why? Because here we have the presence of H proton. But mister, we have here OH with that attached, or hydroxyl group that attached with benzene. What will happen here? Here we have the benzene ring, it makes attraction force with what? With the oxygen. So the hydrogen is very easy to lose from what? From the oxygen bond. Again, we have OH bond here. OH in hydroxyl group, it's very strong. But here in phenol, the attraction force of the benzene ring for the electrons on the O, or the oxygen atom, it makes the hydrogen, it's freely to move outside this compound. So the acidic property due to the presence of hydrogen proton here. It reacts with sodium metal, forming hydrogen gas, as we see here. Here we have the chemical properties of phenol. Due to the polarity of OH, it means what? The polarity of OH, it means hydrogen, it has positive proton, and the oxygen, it has negative what? Negative charge. Here the bond, it increases by the presence of benzene ring. Benzene ring attract the electrons of oxygen atom, and they make the hydrogen is free to move out from the compound. So here in this reaction, if the phenol react with sodium, for example, So we have sodium. This benzene ring, it makes hydrogen move away or evolve from the reaction. So the sodium replaces hydrogen here to make what? C6H5ONa, sodium phenols. Sodium compound with what? Sodium salt of phenol. So here this sodium, it's replaced the hydrogen to form C6H5ONa plus what? Plus hydrogen. So the hydrogen is evolved from this reaction. It's very important to know the chemical property. Why? Because we have in the exam, we have a question about what? About what is the effect of sodium with phenol? So I must write the reaction like this. C6H5O6 or benzene ring with OH plus Na give us C6H5ONa plus what? Plus hydrogen that evolved from the reaction. So the sodium substitute hydrogen from the phenol here. Why? Or give reason? Because we have the hydrogen is freely to move. Hydrogen proton is freely to move due to the effect of benzene ring that attach the electrons of oxygen atoms. We have another chemical property of phenol. It doesn't react with HCl due to the strong bond between oxygen and the hydrogen in hydroxyl group. It's different, completely different here. We have it doesn't react with HCl. Yes. Why? Because it has acidic property of phenol that contains hydrogen proton that move freely from what? From this compound. Again, so the two acids here, HCl and what? And the phenol doesn't react to each other because the strong bond between hydrogen and oxygen. So what? We have it's impossible to eliminate the hydroxyl group from phenol during reaction with acids. Again, you must understand this. It is impossible to eliminate, to move out the hydroxyl group from the phenol during what? During reaction with acids. Why? Because phenol, it has acidic property like acids, like HCl, like H2SO4 and so on. So it is very, very impossible to move out this hydroxyl group. Due to what? Due to the strength or strong bond between oxygen and hydrogen in the hydroxyl group. Hydrogen and oxygen, they are very strong to bond to each other or together. Why? Because we have one of them, the hydrogen is positive and the oxygen is negative, so it makes the attraction force between them very strong. And it is what? Covalent bond. Covalent bond is very strong or stronger than any type of bond. We have nitration of phenol. What's meant by this? Phenol react with concentrated nitric acid. Concentrated in nitric acid. The acid here, or the nitric acid, it is one of the acids that makes reaction with phenol. So in the presence of sulfuric acid. Why? Sulfuric acid, it makes what? It makes the absorption of water from this one, from the reaction. If I have water in this reaction, sulfuric acid absorb it. That helps to absorb water from the reaction and form 2, 4 and 6 trinitrophenol, which is known as picric acid. Nitration of phenol. Here we have the reaction. Phenol plus HNO3 give us what? Give us 2-nitrophenol. And the hydrogen or hydroxyl group, it's in its place, doesn't move or doesn't replace. And we have NO. That makes what? This NO makes what? Makes the reaction. Makes the reaction here and substitute one hydrogen atom. Why? Because here the hydroxyl group that pointed or direct this compound or this group NO to the second one, the second carbon atom of the benzene ring. It directs it like this. So the first one, we have 2-nitrophenol plus H2O. And we have phenol, okay, that makes reaction with another HNO. So it has what? It has 4-nitrophenol. 4-nitrophenol. Why? Because OH, it makes direction or change the direction of NO, pointed it to what? To NO2. So the OH give us or make the NO2 group, nitro group, in what? in the 4 position of the carbon on the carbon number 4 in the benzene ring, plus what? Plus H2O. So in the last time we have what? We have the hydrogen, or we have phenol that react with 3HNO. So here the NO2, it makes direction in 2,4,6 trinitrophenol. It's called picric acid. So this reaction that's happened here, because what? Because we have the OH is found in benzene ring. If I have no benzene ring, we have this substitution of the NO2 nitro group by what? By the hydrogen atom from any one of these carbon atoms. So here the OH or hydroxyl group pointed this NO2 to 2, 4 and 6 plus what? Plus 3H2O. Dear friends, I hope to enjoy your time with us. Till we meet again in another part of organic chemistry. Till we meet again, thank you and goodbye everybody.